Alright guys, welcome back to the bench. And today we're going to be looking at this voltmeter project, which is really just an example of how to use an I2C device, in this case the ADS1115, with an ESP8266. I'm also using this I2C OLED display. So first let me just show you how it works. I have these two wires here, the red and the black, which are my probes. I connect a battery, and as you can see, the voltage is measuring 1.61, and that's just pretty much as soon as I got a good connection, and then it drops down to 0. So let's go through the pieces. First we have obviously the microcontroller. This is an ESP8266. This particular board is a WeMOS D1 Mini. Here I have connected to the 5-volt pin is the positive of this I2C bus, or I guess the I2C bus is just the SDA and the SCL, but along with it go a plus and minus, or a VCC and ground, and we're using 5 volts on that. And the ground is attached to the black wire. Here I have the blue wire attached to pin D1 on this WeMOS D1 Mini, and the D1 is our S clock, and the yellow is connected to pin D2, which is our data pin, or SDA, serial data. And these connect up right here to this ADS1115 chip. You'll see I've soldered this chip so that you can read the pin names. So it is actually upside down, but the V pin is at the bottom here, and that's a voltage. The logic levels on this are actually 3.3 volts because that's what's produced by this ESP8266. But I don't seem to be getting correct voltage readings if I don't power this chip with at least something like 4.5 volts. So that's what we're doing. We're powering it with the 5 volts, and you can see the ground is here in the next one, and then SCL and SDA, and that's serial clock and serial data. Then up here on A0 and A1, I have these two leads, and those are the ones that I connected to the battery. As you'll see, the I2C bus is continuing on this side. Really, these are just duplicated of the wires before, and they continue up here to this OLED display. You'll note that the order is different here. The first pin is ground, and then VCC, but then just as before, the blue comes before the yellow, and that's, again, serial clock coming before serial data. And because of the simplicity of the I2C bus, we can connect both of these peripherals up using the same 4 pins, and that allows us to have a really simple circuit, which is pretty easy to see. So this ADS1115 is a 16-bit basically voltmeter, or analog to digital converter, which turns a voltage into a number. So it's a 16-bit number that it's producing, and it has a programmable gain, so you can choose how sensitive it is, basically. Right now it's set on the least sensitive mode, so that its maximum range is somewhere in the neighborhood of 6 volts. I'd have to look up exactly what it is. And as you saw before, as soon as I connect up the battery completely to it, it's reading 1.612 volts. So now I just want to quickly show you how that compares to another voltmeter. In this case, the voltmeter I'm going to be using isn't an amazing voltmeter, but it happens to agree 100% with this circuit. I have a somewhat complicated wiring setup here, but basically I have 2 sets of probes attached to this meter, with 2 of them which are alligator clips. I'm going to attach to the probes of the circuit on the board, and that way I can basically tie the 2 together, so they should be reading the same value. And I have this on the 200 millivolt 2000 millivolt range, so I have similar precision. And then if I connect this up to my battery again, I get 1.612 and 1.6122 on the other one. So very, very close to each other. However, if I use my slightly better meter, I get a lower reading. And I don't have any way of telling whether or not this meter is more correct than this meter, but I'll just show you that in a moment. Alright, we're connected to the slightly better meter, and sorry, that's on the wrong setting, and it's reading 1.606 volts on that one and 1.6125 on the homemade one. So there is a small difference there. I mean, it's really quite small. It's a hundredth of a volt or so, but it is different. So I'm not sure which one is more accurate. Okay, that's it for this short overview video. This is the Voltmeter project. This iteration of it is really just meant as a pretty simple explanation of how to use I2C peripherals that also has some real functional use. If you like this project, please give it a thumbs up. I really appreciate that. Leave a comment if you have a suggestion for something I should do or a way that I could have done this better. And please subscribe if you'd like to get updates or more videos like this. I do hope to be putting out a video explaining the source code in a little while. And the source code will be down in the description, so check that out. Anyway, thanks for watching. Bye.